Hello. Today we're going to wrap everything up with factoring. Basically, we're going to take all the different methods that we learned in the previous videos and we're going to look at how we can incorporate them to come up with a basic strategy and approach to take when we're looking at any polynomial and we want to factor it completely. Okay, so when we're looking at a polynomial that we're trying to factor, our basic strategy, the first thing we want to do is look for and factor out the greatest common factor if needed. So now I mentioned this before, look for the greatest common factor of all the terms, extract that, and then after that, what you want to do is count the number of terms. As I said before, the number of terms is going to determine the method that you use for factoring. So if you have a 4-term polynomial, what you're going to do is factor by the grouping method. And we covered that in an earlier video. Then if you have 3 terms in the polynomial, it's a trinomial. And remember, there were 2 types of trinomial factoring. One where the leading coefficient is equal to 1, and the other where the leading coefficient is a number that's other than 1. And there were different ways of approaching those. And there were videos for those that you can check out as well. If you have 2 terms, that falls into the category of special forms, where we have the difference of 2 squares and also the sum and difference of 2 cubes. And for those particular methods, if you recall, there were formulas that we applied to factor those out. So that's your basic strategy there. Now, once you get to the end of that, you count the number of terms, you use the appropriate strategy. Once you get to that answer, you want to check those factors to determine if additional factoring can be done. And this is one of the most common mistakes that's done with factoring, because you can factor correctly, but not factor completely. So make sure that once you factor, or once you do that first wave of factoring, check those factors to see if there's anything that can be done any further with the factoring. So let's get into a couple of examples and we'll show kind of how we follow this strategy. Now for our first example, we're going to look at this: a cubed minus 45 minus 9a plus 5a squared. So it's oftentimes a good idea to get the terms in the right order, and usually when we say the right order, that means that we want the terms to be written in descending order, descending powers. We'll have a cubed plus 5a squared minus 9a minus 45. What was the first step? We'll look for the greatest common factor. When we look at the terms here, there is no common factor among all 4 terms. So then our next step is to count the number of terms. So here we have a 4-term polynomial. We want to apply the grouping method. So with the grouping method, we pair off the terms. First pair has a common factor of a squared. Factor out a squared, we'll have a plus 5. Bring down the negative or the minus sign. The second pair of terms has a common factor of 9. So extract the 9, and then that gives us a plus 5. Since we're factoring out negative 9, we change the signs. So now we see that in both of these groups, we have a common factor of a plus 5. A plus 5, what's going to be left over is a squared minus 9. So now we factor this correctly, but it's not factored completely, because notice that a squared minus 9, that's the difference of 2 squares. So we can apply the difference of 2 squares formula. 9, a squared is going to be a squared, 9 is 3 squared. And so bring down a plus 5. And when we factor out a squared plus 9, that's going to be a plus 3 times a minus 3. And so now none of these factors can be reduced any further. And so this would be our completely factored form. Let's take a look at another example. In this example, we have 128x cubed plus 54. Look for greatest common factor. Here, both of these numbers are even. So looks like we'll have a common factor of 2. Factor out the 2, that gives us 64x cubed plus 27. Once we factor out the 2, we look at what we have left over. How many terms do we have here? Got 2 terms. If this is going to be factorable, it needs to be one of the special forms. So we're looking at the sum of 2 cubes. Recall the formula for the sum of 2 cubes. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. We know that 64x cubed, that is 4 x raised to the third power, and 27 is 3 raised to the third power. Our first factor would be 4x plus 3. Our second factor will be a squared, or 4x squared, minus a times b, or 4x times 3, plus the last term b squared, or in this case 3 squared. Let's clean it up. So we have 2 times 4x plus 3 times 16x squared minus 12x plus 9. All right, so here, none of the factors that we have remaining can be reduced anymore. So at this point, we're done. This is our factored form. Let's take a look at one more example. We're going to look at 6x cubed minus 28x squared plus 16x. All right, so once again, first thing, look for a common factor among all the terms. Here, there is a common factor among all 4 terms. Common factor is going to be 2x. So if we extract that, we have 2x times 3x squared minus 14x plus 8. Next thing, count the number of terms. Here we have 3 terms in the polynomial, so it's going to be a trinomial. Notice that the leading coefficient is 3, that's not equal to 1, so we're going to have to use the alternate factoring method for this part. We're going to do the AC method. We want to look for 2 numbers whose product is equal to a times c, or in this case 3 times a, which is 24, and whose sum is equal to negative 14. 2 numbers here will be negative 12 and negative 2. Break up the middle term. We have 4 terms here, and we factor this by the grouping method. So pairing off the terms, I'm going to use brackets here just to distinguish the grouping symbols. So in the first pair, we have a common factor of 3x. Take that out, x minus 4. Bring down minus. Second pair of terms has a common factor of 2. Factor out a negative 2, we change the sign. That'll give us x minus 4. And so now both of those groups, having x minus 4 in common, we'll have 2x times x minus 4, 3x minus 2. So examining those factors, we cannot reduce them anymore, and so this would be our factored form. This concludes our series on factoring polynomials. Hopefully this was of value to you. If you have any questions or you have any comments, or if there are any types of problems that you'd like to see being done, you can leave those questions or comments in the comment section below. I'll be sure to get to them as quickly as I can. And if you like the video, please feel free to smash the like button, to subscribe. I plan to do a whole lot more videos. If there are topics that you would like me to go over, also leave that in comment section. And I hope you guys have a good day.